In optimization, we saw how the derivative of a function can help us to maximize the area of a rectangular shape, minimize the distance, and doing all sort of stuff. But those word problems involve finding the maximum point or the minimum point on the graph. Very often, we actually need to find something else, such as the rate of change on one variable on another one. In math, there are a lot of relationships that will give us that will involve different variables. Like when you are filling a cylindrical tank of water, how fast can you fill up the tank when the water is changing at a certain centimeter per second? Or let's say if you are a warehouse manager, you want to increase production over time. How much workers should you hire to speed up the production? In these cases, it is important to find the relationship between the variables, the rate of change of which are given and required. Now, since many of these rates of change are with respect to time, we can then differentiate a given function with respect to time. And we are going to use implicit differentiation in many of these examples. Here in example number 1, given a cube with 10 cm for the side length, how fast is the volume increasing if the side length is increasing at 2 cm per second? When we are talking about a cube and you're tracking out its volume, it is important to set up your equation first. Volume of a cube equals the cube of its own side. So if you can set up an equation first and differentiate the function with respect to time, we will then end up with dv dt on one side, and on the right hand side, as you differentiate x cubed, using the power law, we will end up with 3x squared. But since we are differentiating this variable with respect to time, we need chain rule to finish it up. So once we have dv dt equals 3x squared ds dt, we can then figure out the speed of, or how fast the volume is changing by making a substitution using the side length, which is 10 cm long, and then the rate of change on its side length, the change of its side length with respect to time, which is 2 cm per second. As you substitute these two numbers into the equation, we can then figure out the volume, the change of volume of this cube.